So we've improved our chances here, I think, with a 3,000 cubic foot per minute fan, variable speed, or sorry, I should say selectable 3-speed fan. Doesn't say what the 3,000 cubic feet per minute is on the first, second, or third speed. My guess is it's probably in the top one, but once we figure out how to add this to our air cooling situation, we'll start in the lowest speed and work our way up from there. So this is the fan here. I've taken its grill off. Let's have a closer look at the mounting options here. The variable speed switch is here, and we have this pretty nice looking chrome, I don't know what you call this, a wind tunnel, I guess, but I'm thinking that I'll probably use this flange to mount it directly to the box. You see the orientation of this cabinet was always meant to be at the back of the power shed, with the air intake being on one side and on another side the exhaust, those two sides being here and here on the power shed, exactly the two sides that are facing away from the cabin. That was entirely deliberate. That would have been two places that noise would be escaping. So doing the math on this, for surface area of a circle, we've got about 170 square inches to cover here. And our exhaust ports are currently just less than 20% of that. So the other problem is, do we use this fan to push air in, or do we use this fan to pull air out? Again, part of the challenge here is where do I fit a 14-inch intake or output on the cabinet and make sure it gets vented to the exterior. On this side, the intake comes into its own compartment, which is only 5 inches wide, and the baffle forces the air down to draw it through the generator and up out of the other side. So clearly that design is now a little outdated. I'm going to have to get a lot more air into the cabinet to be able to draw it out with something as powerful as this. So on the other side of the cabinet, I think that's easy enough. I just cut a big hole in the side of it, I mount this on, and I vent it to the exterior of the power shed. I'd have a grill of some sort, a louver I guess is the proper term, to prevent the rain or anything else, critters getting in. This side, however, I'm going to need around 170 square inches of surface area air intake. Not sure how I'm going to do that quite yet, but hey, that's why I'm out here. Boom. So I may have been talking a little out of turn on the actual math here. I'm going to create a hole that's about 13.5 inches wide, possibly even 13. So 13 divided by 2 gives us our radius of 6.5 times 6.5, because it's your radius squared, gives us 42.25 times pi, 3.1415. So we're at around, I don't know, roughly 132.75 square inches of area. Now the reason that I want the amount of area on the intake the same as the output is that I don't want to put too much stress on the motor of the fan, because then it won't last very long. If the hole is too small, the fan will just get it'll get really stressed, and may experience some sort of burnout. So the other idea here is maybe cutting a pair of holes here for duct work that I can elbow out, because I don't think the side is going to work very well. I would need some kind of crazy custom duct work to port it in from the outside. And the math actually works all right. So if I had a 14-inch hole pulling the air out, it's about 153 square inches, and I'd say 2 10-inch, that's 5 times 5, 25 times 3.14, 78 times 2 would bring us to around 160, 156. That matches up very, very nicely. So I can also get myself some 10-inch round duct work that's commercially available, as opposed to something that's custom made, extra work for me and additional expense, although I think I've pretty much blown the budget on this one. So I must say that I'm pleased I didn't glue this thing together. Can't even really say why, because that is unnecessary. And let me tell you, if she was PL'd together, I think things are a heck of a lot more difficult to modify. Now I cut here because obviously I wanted to, well, ideally wanted to cover both holes, but there's just no way of doing so. So I know it'll get a little ugly, but I'll just patch this up with something else. Still not sure whether I'll use that for the exhaust. Probably still will. Alright, so a quick little tour before we seal her up, get the generator back in, and have a test shot. 2 10-inch holes with a surface area roughly equivalent to 1 14-inch hole, which you'll see in a second. I sealed up the 2 4-inch holes, a little bit of glue and some screws. And wandering back over here, made a 14-inch hole. That's where our fan is now. Use drywall screws, fasten it in. They've got an aggressive thread, and the black kind of blends in there. And of course, sealed up the other 4-inch hole. That for now will remain to be our exhaust. And all I've got left to do is take that can of sorts, or duct, and mount that to the edge of this, and then we'll seal her up and give her a shot. Use as intended. So I'm aware that there's a trade-off. You're making bigger holes for more airflow in a soundproof container. You're going to let more sound out. As simple as that. Trade-off that I have to make, though, clearly, because the previous iteration of the box here was not sufficient. So we'll take you on one more walkthrough around it. On the inside of the box, the variable speed controller is easily reachable. We're going to start the first test shot on the lowest speed. Obviously, this is the least noise. If that works, great. It's the least power draw, it's the most efficient. And if it does not, we'll increase the speed until we find out what does. I've got the thermometer hooked up, and just like the first time, we're going to see how long it takes us to reach 40 Celsius. And if we don't at all, then that's an absolute win. It's getting a little dark, but kind of see the gist of it. There's the surround of the fan mounted to the box, and there's our thermometer hookup. Currently 0.7 Celsius. And what I'm likely to do is turn the generator on here, and we will plug. I can't even see it. This is no good. So yesterday ran out of time. Things got a little dark for making a movie, and well, most of today has been spent on déneigement. Lots of snow, lots of snow. So we're gonna test today. It's unfortunate that this whole project started out as this generator is too loud. It's turned into more of a cooling experiment. Obviously, if you're going to put bigger holes in a soundproof enclosure, it's not so soundproof anymore. It'll be in the power shed, so it'll have some soundproofing or further sound deadening qualities there as well. So anyhow, we'll take one quick tour before turning her on and seeing what we can see. The difference this time around is well, we have air movement that's well over tenfold of what we had previously. I'll turn it on. I'll even attach the fan to it so that there's a little bit of a load on the generator. And we'll have a look-see at the thermometer there and see how long it takes to heat up. Well, it's 10 minutes, took it to 30 Celsius, so that's pretty awesome. But I think maybe another 10 minutes, it'd be at 40, so I'm going to turn the speed up a little bit on that fan. So we've gone from the low speed setting to the medium speed setting, and this time I'm going to add a load to the generator as well, a power tool of some sort, 1,000 watts maybe. So I mean, power that this set will easily handle, so we'll see if that makes a difference on how quickly it gets heated up. It is with some surprise that this pipe's not done any damage to the MDF, either on the inside or the outside. MDF's kind of like, it's like paper and there's glue in it. I would imagine around the same combustion point as paper, maybe 400 Celsius. So I've been monitoring that. It's not something I've actually said in any of the videos, but I haven't needed to wrap it in any sort of skin, you know, high heat product yet anyway. table saw. Left her running for about 15 minutes, and she kind of steadied out at around 37, 38 Celsius on the number 2 setting. Attached a load for a couple of minutes. A table saw, it's probably draws 12, 13 amps. Now this generator set's not going to really see a workout until I hook it up to our solar power system. The inverter on that system's got a 240 volt draw, which really is what you need to give this set a good workout. You know, up around 4,000 watts to charge the batteries. So that's kind of going to be the true test. I think for now, in the top setting, that air cooling, or the air mover here, is definitely sufficient for now. Still not super thrilled, but the sound deadening is quite minimal, according to the crummy little app I've got. 2 to 3 dB, but to my ears it sounds like a little bit more. I do know somebody that's got a dB meter, a proper tool, so I will likely borrow that. And the conditions in here are kind of crappy too. You know, we're surrounded, we're in another box. Ideally, what I want to do is have this, say, in the backyard and do a comparison test that way. But hey, this thing's getting a little out of hand, so I think I'm just going to pack it up, put it in storage until the spring, and that time we can look at it all over again. Cheers.